no fresh SpaceX hardware or mission updates appear in today's reporting, so the focus stays on steady progress across reuse and refueling goals. This is SpaceX Daily, episode 52. From an engineering standpoint, Starship's architecture centers on separating the Super Heavy booster's recovery from the ship upper stage's re-entry and landing, because each stage faces fundamentally different thermal and structural loads. The booster must return from roughly 100 kilometers altitude with a relatively modest heat pulse, allowing a tower catch that reuses the same structure for the next flight within days. The ship, by contrast, must survive a full orbital velocity re-entry that deposits far higher total energy into its heat shield, which is why the current tiled approach is still being iterated even after multiple flight tests. If the raw material cost of the booster's propellant and structure is treated as the floor, every reuse cycle lowers the effective per-flight cost by spreading that fixed mass across additional missions. The idiot index for a single-use booster would therefore be the full manufacturing price divided by the propellant plus metal cost, a ratio that drops sharply once catch reliability is proven. The same logic applies to the ship once its thermal protection system reaches a state where tile replacement between flights becomes the dominant turnaround variable, rather than full refurbishment. The booster's grid fins and skirt must also survive the catch loads without deformation that would force lengthy inspections, because any added ground time directly multiplies the per-flight cost. The open variable remains how quickly the combined stack can move from one flight to the next without accumulating hidden inspection or repair overhead. Each successful booster catch that avoids damage to the grid fins or skirt shortens that loop, while any ship tile loss that requires extensive rework lengthens it. Watching the next flight test will show whether the current tile attachment scheme has closed that gap enough to support the rapid reuse cadence the program needs for later refueling demonstrations. A second key constraint is the propellant transfer interface between stages, because the booster must deliver its remaining propellant margin precisely enough that the ship can top off its tanks without exceeding structural or thermal limits on either vehicle. That interface is being validated through a series of increasingly complex on-orbit tests, each one adding data on flow rates, thermal conditioning, and docking alignment tolerances. Because the booster returns to the tower and the ship continues to its landing site, the two vehicles can be processed on independent timelines once the catch and re-entry phases are complete. This separation of recovery paths is what allows the overall system to target flight rates that would be impossible if both stages required the same ground infrastructure. The next measurable milestone will be whether a single booster can complete two flights with only routine inspections between them, confirming that the catch hardware itself does not introduce new life-limiting damage modes. Once that data point exists, attention will shift to the ship's heat shield performance after multiple orbital entries. The tiled system must demonstrate that individual tiles can be replaced without disturbing adjacent ones, because any requirement for large panel removal would collapse the reuse economics the program is built around. The first principles trade-off is therefore straightforward. Every kilogram of inspection or repair labor that can be eliminated multiplies the number of flights the same hardware can deliver before its cumulative cost exceeds that of building a new vehicle. Worth keeping an eye on Blue Origin's ongoing LC-36 rebuild after the May static fire explosion highlights how pad anomalies can reset test timelines for a new heavy lift vehicle. An issue that would be resolved only by completing the structural repairs and confirming alternative second stage test hardware performs as planned. Observers noted continued pad reconstruction work at Blue Origin's LC-36 site after the earlier New Glenn static fire loss, with alternative second stage test plans now under review. The effort follows the May explosion that destroyed a New Glenn vehicle during a static fire attempt, prompting both structural repairs at the Florida pad and parallel work on off-site testing hardware for the second stage. Source reporting indicates the rebuild is active 2 months after the incident, with the company evaluating multiple paths to resume second stage validation without waiting for full pad restoration. While Blue Origin works through ground infrastructure resets, the broader market for large satellites continues to attract fresh capital. Rocket Lab secured an additional multi-launch agreement with Japan's IQPS for radar imaging satellites using the Electron vehicle. The new contract adds to an existing relationship and will use multiple Electron flights to place additional synthetic aperture radar satellites into orbit. K2 Space closed a $500 million Series D round to scale production toward 100 large satellites annually for both commercial and defense customers. The funding more than doubles the company's valuation in 7 months and will support a dedicated manufacturing line capable of turning out up to 100 spacecraft per year. On the AI front, no sourced developments on the SpaceX AI Grok Cursor compute thread appeared in today's reports. The live threads remain orbital data center concepts, direct-to-cell backhaul scaling, Colossus cluster growth, and Grok distribution inside developer tools. A quick note on the tape shows SPCX closing at $108.37. Before we go, the next measurable milestone on the propellant transfer interface will be the first data point from an on-orbit test that confirms flow rates stay within the thermal limits of both stages. That's your SpaceX news for today. SPCX is trading at $108.37, down 3.9%. If the show saves you time, a rating or review on Apple Podcasts or Spotify genuinely helps new listeners find it. I'm Patrick in Vancouver. Thanks for listening. See you tomorrow. One more thing. If you liked today's episode, our sister show, The Do Positive Pod, is worth a spot in your feed. Good news in science and tech, plus one concrete action you can take. It's one of the NARA Network's daily briefings, all free at naranetwork.com. Live dashboards, TSLA, SpaceX launches, the investing scoreboard are all at naranetwork.com data. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.